everybody, how are you? Ready to learn some fun and exciting SPSS stuff today? Okay, well, you're going to learn it anyway, so if you're not excited, that's fine. So today we're talking about independent t-tests and paired t-tests. So your textbook goes into a lot more detail about the math behind calculating these in SPSS. I don't expect you to memorize those formulas because that's just crazy, and you're never going to do that in the real world because you will have too much data. So I'm more concerned that you know how to enter data into SPSS, run these tests in SPSS, and then from that output, identify what you need to know from the output. So I know the textbook is super intense, but we're not going to get that intense because it's just too much. But if you are curious about how SPSS calculates this stuff, you can read it because it tells you exactly how it does it. So this is just from the syllabus, the course objectives and outcomes from today's class. If you're interested, I'm not going to read them to you. This we'll be using for the rest of the semester, the matrix of statistical tests. Believe it or not, by the end of the semester, you're going to know all of these tests in this middle part of the table. So today we're just talking about the independent t-test and the paired t-test. We did these z-tests and t-tests last week. Next week is the chi-square, which is this x squared symbol, and it kind of goes in a bunch of different places. Oh, maybe next week's ANOVA. I don't remember. One or the other. We're going to learn both of them. And then some of these weird looking named ones are non-parametric tests, and we're going to go over them briefly the last week of class. So for the most part, the ones we're going to use most frequently will be the independent t-test, paired t-test, one-way ANOVA, repeated measures ANOVA, and the chi-square. So those are going to be our big ones for the rest of the semester. But today we're just talking about independent and paired t-tests. So this table shows a lot of different things, and it might not work for you. This is how my brain works things. If not, on D2L, on the content module overview page, there's other decision tree websites you can go to, and if those work better for you, that's totally fine. But this is what works for me. So either way, we'll come back to this, and it'll make more sense the last day of class than it does right now. So two sample significance testing. So last week we talked about one samples and trying to estimate the mean if we had some information or estimating the population's mean. Now we have two separate samples and we're trying to see if there's a difference between them. Ooh, fancy, exciting. So this t-test, the two sample t-test, applies if you know you have a continuous dependent variable, or DV, and it differs by a dichotomous, or two-categoried IV. Or if there's a statistically significant difference between the means of two samples, or if the dichotomous independent variable contributes to the variability of the continuous DV. Now those last two are really confusing. So the main thing to remember is if you have a continuous DV and an IV with only two categories, so like male, female, yes, no, good, bad, you have two categories, that's where we're at. Cool? Cool. So overall, two samples or categories, the DV is in independent groups, the independent t-test. So that would be if you have a group of males and you're comparing them to a group of females, they're independent of one another. You cannot be in both groups at the same time, according to this. Or if your response to a question is yes, your response can also not be no. So they're independent. You can't have both at the same time. Dependent or paired groups is when you use a paired t-test. So this would be if you're measuring the same group of people before a program and after a program. Or if you're measuring, I don't know why it's going ahead by itself. That's not very exciting. Or if you're measuring the comparison between wives and husbands in a group. That one's confusing, so for the most part in this class, we're only going to use pre and post test for a paired t-test. Okay, so the independent t-test, exciting. So the typical questions that this will answer, some examples. Has the quality of life improved for patients who took drug A as opposed to patients who took drug B? So this is two groups of people, the group who took drug A and the group who took drug B. And we want to see if the quality of life for those two groups is different. Another question could be, are men more satisfied with their jobs than women? So here we're looking for job satisfaction and comparing between men and women. Do patients receiving outpatient care spend more on health insurance than patients who receive only emergency care? So here our groups are people who receive outpatient care versus people who only receive emergency care. And we're looking to see what their average cost of healthcare is and if it's different between the two groups. Does that make sense? So in all these examples, there's two groups and you can't be in both groups at the same time. And the continuous dependent variable means that you're going to be able to find a mean and standard deviation because continuous means that it's a numerically measured variable. Everyone remembers that from back in the beginning of the semester? If not, you will, because that's what we're going to talk about. So here's an example, a more step-by-step example. So one group of patients are administered an 8-week weight loss program. They're only assessed after the program on demographics, knowledge. So demographics are like weight, age, gender, income, those kind of things. Knowledge, intentions to maintain healthy behaviors, and BMI. So we want to know from this group of people, is there a difference between the post-program mean BMI between the males and the females? So here we're first going to identify the dependent and independent variable. So the dependent variable has to be continuous because we're using an independent t-test. So of the variables listed here, what's continuous? BMI, because that's measured, in this case, we're going to say it's measured on a scale of theoretically 0 to probably around 50 is like the highest. So it's on a scale, it's a range. That's why it's the DV, because it's continuous. The DV in an independent t-test will always be continuous. The IV in this example is gender. So when I'm asking in the homework for the scale of measurement and if it's nominal or ordinal, the categories, I'm looking for you to say that the DV is continuous and the IV is either nominal or ordinal. And then so in this case, gender is nominal. And then the two categories are male and female. So that's what I'm looking for you to identify in this homework 7 when I ask for the categories and the scale of measurement. Since these are independent categories, that's how we determine that this is an independent t-test. So using that same kind of example, we're going to want to see if the post-program BMI is statistically different between the people who participated in the program versus some other group that we have hanging out somewhere who did not participate in that program. So what's our DV in this example? Anyone? BMI, because it is what we're looking for. Then the IV is the program group, because we want to compare the difference between that DV or BMI between the people who participated, group 1, and the people who did not participate, group 2. So program group would be the IV, it's measured nominally, and the two categories are the weight loss program versus that other group that we have hanging out waiting. Since these two groups are independent, you can't be in the program and not be in the program at the same time. This is an independent t-test. Okay. So this shows how you're supposed to enter the data into SPSS. So each row of data will be one person in your study. And you'll have one column for the DV and one column for the IV. So this is the part that gets people confused, is you're going to assign a value for each IV group. So maybe we have 1 as the program group and 2 is the other group, that off on the sidelines group. So when you're putting them into SPSS, you have to put the 1 and the 2 and then go on to that variable view page and type in what those mean. We're going to go through some examples on SPSS too, don't worry. But first we're going to go through the lecture part. Does that make sense to everyone? So this first row here is one person, which is super exciting. And then row 48 down here is another person. They had a BMI of 27.0 and they were in the control group. Whereas this first person had a BMI of 25.0 and they were in the program group. Okay. So the procedure your book goes through does all of these steps by hand. Since we're not going to do that, I'm just going to talk you through them because this is what SPSS is doing, like behind the scenes when you press the button to run the test. So it's thinking of the null and alternative hypothesis, which we talked about last week, the significance level, which is 0.05, always forever in this class. Then it's going to compute that test statistic that we're looking for, the t-test in this case. It's going to determine that critical value, and then it'll give us output. And then from that output, we're going to say that we either the test statistic is higher than the CV, then we're going to reject the null hypothesis. If it's not, then we're going to fail to reject it. But it's going to be a lot easier when you look at it on SPSS because you just look to see what the number is. And then you write out the conclusion. So an example of sort of going through this. Does the maximum number of alcoholic drinks consumed in one day in the past month statistically differ between male and female college students? Look, that's not the DV, never mind. What is the DV in this case? What do we think? We know it's measured continuously. The number of alcoholic drinks. So, since that can be measured on a scale of 0 to, I don't really want to know how many, a lot. We'll say 10 because I'm going to be not generous. That's a scale, so that's continuous, so that's our DV. What's the IV, or independent variable? Gender, and then it's measured, is it measured continuously, nominally, or ordinally? Nominally, and what are the categories? Male and female. Awesome. So, since the categories of male and female are independent of one another, what test are we going to use? The independent t-test. Yay! So then we do some fun stuff. We have all this data and we get these numbers from it. We're not actually going to do that because it'll do it for you in SPSS. But you get these numbers. There's 54 males and 85 females. The mean for males is 8.2 drinks. The mean for females is 5.6. The standard deviation is this bottom row here with 5.9 for males and 5.7 for females. Okay, so then in the way your textbook goes through to describe it is you first state the hypothesis. The null hypothesis is that the male's mean number of drinks will be the same as the females. And then the the alternative hypothesis is that they won't be equal. Then we determine our level of significance, 0.05, because that's what we're using in this class. What test we're going to use, the independent t-test, because we just talked about that with the variables. Then, I skipped a number there. Whoops. Then you're going to click some buttons in SPSS, and then you get your output. And then in the output, you'll find your test statistic, which is 2.60. And this shows, there's also a p-value in the output, and it's less than 0.05. So since it's less than 0.05, there is a statistical difference. So this is one of the write-ups that I'm expecting you to use for your homework. And there's another slide that tells you what exactly, but the conclusion in this case would be an independent t-test found that a higher mean number of drinks was reported for males, and then it has the mean and standard deviation for males, as compared to females. Mean standard deviation. T, parentheses, the degrees of freedom value is equal to the value that's T in the table, and then P is less than 0.05. So this is the tip to remember. If the P is less than 0.05, there is a statistical difference. If P is greater than or equal to 0.05, there's no difference between the two groups. Okay. Now I'm going to show you some examples in SPSS before I talk about the paired t-test so that you aren't super duper confused. But you might be anyway. Is anyone really confused? So, no. It didn't show up on your screen, but stuff just popped up on mine. And I'm like, ah! Okay. So the paired t-test. The typical questions that are answered with a paired t-test are, is there a difference between before and after, pre, post? That's all I'm going to ask you in this class, because otherwise it gets really confusing. But you can also have matched pairs, which is what I was trying to explain before. If the mean stress scores are different between wives and husbands in a group, but then it gets confusing and that's really difficult. So we're not going to do the matched pair ones in homework or really anything, but know that that's in existence out there somewhere. For this class, it'll always be either before and after, pre, post, something of that nature, time. The IV will be time, and there will be two categories, and it'll be a paired t-test. And the DV will be continuous. So some examples of time. Is BMI statistically different from before to after a weight control program? So BMI is measured continuously. That's your dependent variable. And then before and after, or time, is your independent variable. Knowledge scores increase from before to after health education class. Here, the knowledge score is your dependent variable, and time before to after is your independent variable. The effectiveness of a diet is tested using weights of subjects measured before and after the diet treatment. Each before value is matched with the after value because each before and after pair of measurements came from the same person. So what is the DV in this example? Remember, the dependent variable is continuous. Weight. the weight is your dependent variable because we're trying to see if weight is different. What's the independent variable? Time, before the program and after the program. So this is one group of subjects that were measured at 2 time points. So you could also think of this as, this is you and you're measured at a midterm and a final as your exams. The midterm's your pre-test and your final is your post-test. You want to have a better score on the final than the midterm. Or you want a good score on both of them. But do you understand what I mean? If you did really badly on the midterm, you want to do really well on the final. Okay. So here is an example, another example. So is BMI reduced as a result of a weight loss program? Again, BMI is your continuous dependent variable. And then testing, assessment, time, however you want to refer to that, is measured nominally with a pre-test versus a post-test. These are dependent categories. You have to be in the pre-test and the post-test. You can't just be in one, or you can't tell if you did better at the end or not. So since they depend on one another, or you have to be in both, you get a paired t-test. Okay. So to enter this data into SPSS, each row is still one person, but now you have one column with their pre-test score and one column with their post-test score, or one column with their before and one column with their after. So in this case, this first person had a their first BMI was 26.1, and after the program, their BMI was 25.0. And number 49's pre-test BMI was 28.4, and their post-test was 29.2. Okay. So another example, in a group of 15 adult males, is the pre-treatment systolic blood pressure statistically different from post-treatment systolic blood pressure? So here are your hypotheses. So this is going through those step-by-step, like your textbook talks about, in way more detail. So your null hypothesis, your alternative hypothesis, we're going to use an alpha level of 0.05, and we're going to use the paired t-test because you have samples that are dependent on one another. Then you're going to click some buttons in SPSS, and then you get your output. And your test statistic of 7.983 has a p-value that's less than 0.05, so we reject the null hypothesis, and there is a statistical difference. Yay! So that means that this would be another way to write out that conclusion. So paired t-test found that the mean serum cholesterol measured in milligrams per deciliter was statistically reduced from baseline or before mean and standard deviation to post-program or after with a mean and standard deviation. T, parentheses, degrees of freedom, equals the t-value, p less than 0.05. Remember, if p is less than 0.05, that means that there's a statistic difference. Yay! And if it's greater than or equal to 0.05, there's no difference between the groups. Okay. I'm going to keep saying that because inevitably there's at least 2 people that always mix them up on the homework, and then they get questions wrong. So pay attention to those when you're doing your homework. You can also use the 95% confidence interval. We're not going to actually do that in this class, but you can. You can actually calculate this, which your book tells you how to do, but that takes, so the homework that is due tomorrow from last week, homework 6 and homework 5, I made you do it by hand. However, now we're just going to use SPSS because otherwise it would take you like 25,000 years to do this. So you can do it, but we're not going to. I'll show you how to do that in SPSS, and then we'll come back to this. So again, I'm going to pull up this Word document and the SPSS files. So here our question is there a statistical difference from baseline to post-program in the mean serum cholesterol value? So our DV is cholesterol, measured continuously. Our IV is testing time, before and after, baseline, post-program, pre, post, similar words. And so since those are the pre-post, they're dependent or paired, you can also think of it as paired. That might be a little easier. Use the paired t-test. So to find this in SPSS, we go back to analyze, compare means, and now instead of using this independent samples, we go to the paired samples t-test. And then you get a different looking pop-up now. So here we're going to pull over the cholesterol variable, the pre-test or the baseline cholesterol variable, which is what we used before, into variable 1, pair 1. And then we're going to pull over the post-cholesterol into variable 2. We don't need to use options because this uses the confidence interval to give you things, but it's there if you ever want to play around with that. So once you pull those two over, the pre and post cholesterol variables, all you have to do is click OK. And then it pops up here with the statistics, the mean, the standard deviation, and the number in each of those groups. This number, if we're using a paired t-test, should be the same because all of the people in the pre-test are also in the post-test. So if these two numbers are different, you might not be running the correct test if it's supposed to be a paired t-test, or something went bad. So the values you'll report in that write-up are this mean up here in the first box and the standard deviation. And then this one's a lot easier than the independent one because there's only one row of information. So you'll report the t-value, the degrees of freedom, and this sig two-tailed is again your p-value. So since this is less than 0.05, there is a significant difference from before to after. So again, here's the write-up. Either way is fine. You can copy and paste this and change the wording and change the numbers for your homework because then it's easier and you don't have to think of it yourself. If you want to, go for it. And the second one is the APA format fanciness if you're ever submitting an article for publication. Okay, questions about that? Is this easier or harder than the rest of what we've done in SPSS? Neither, okay. Excellent, that's great. That's what I like to hear. Okay, so now we're going to talk about how you're going to decide if one's independent or paired t-test. I don't know why it says dependent there. That was silly. It should be paired. Anyway, you're going to focus on the subjects in your samples. So if the two samples are independent, so you can't be in both groups at the same time, it's an independent t-test. If the two samples are dependent, then the same subjects are in group 1 and group 2. That's a paired t-test. So we already talked about this, but here it is written out for you, so you can print it out and hang it up on your wall and be like, which one is it? Or you don't want to do that, that's fine too. But it could also be, we're not going to use these here, but it could be like a twin group and you're comparing the one twin to the other twin, siblings or the married couple, so you're comparing the husbands to the wives. Or they've been matched some other way, and that gets even more complicated, so we're really not even going to go there. Components of a professional write-up. So this is what I'm looking for in your summaries. And the summaries that are in the Word document and all the ones in this PowerPoint meet these requirements. So it should include the name of the dependent variable, what the sample or samples are, the independent variable, the descriptive statistics, including the mean and standard deviation, the nature and direction of the findings. So what this means is Is it significantly different? Yes or no? Is it higher or lower? And then information about the inferential statistic. That's what I was talking about at the end of the sentence. So what was calculated? Was it an independent or paired t-test? The degrees of freedom, the value of the statistic, the t-value, and then the level of significance. So is it less than 0.05 or greater than or equal to 0.05? So here's an example. An independent t-test found that the mean departure time, this is actually the example from your textbook walkthrough. They didn't write a summary that I liked, so I made my own. So an independent t-test found that the mean departure time for 15 drivers in the intruder group, mean standard deviation, was significantly greater than the mean departure time for 15 drivers in the no intruder group, mean standard deviation, comma, the t-value, degrees of freedom, the actual value, and the t was less than or equal to 0.05. So this is the first example in, I think it's on, I don't know, I have a slide about what pages it's on. But if you work through that yourself, this is the answer you should get. And then the paired t-test, another write-up, found that the average knowledge scores for 20 parents were significantly higher after completing the web-based intervention program, mean standard deviation, than before beginning the program, mean standard deviation, t, degrees of freedom, the t-value, p less than 0.05. So this is what I was talking about. Pages 354 to 358 of the textbook, it has those two examples. The data is listed on different pages, which I have here. So you can enter that data into SPSS and then walk through the steps that it shows you on these couple pages here, and you should get the results that are in those write-ups on the previous two slides, or get the same numbers at least. And it, like the Word document I was using, it has this everything circled where you should be looking and checking. Questions about this so far? Okay. So another thing that we're supposed to learn in this class is how to interpret things that have already been published. So if you're looking at a journal article, what does it actually mean? So this is an example of decreasing decreasing assault on a psychogeriatric ward. So some things I like about this table. It has a title. Yay! It's kind of sort of APA format. This line's kind of weird because it doesn't go all the way across. Okay, whatever. This t for difference is that t-value we were talking about from the SPSS output. I probably would have done the mean with the standard deviation in parentheses so there weren't as many columns, but I'm picky, whatever. And I probably would have said, oh, it did say, oh, haha, the Cohen-Mansfield agitation inventory, that's what this means. Maybe I should read a little bit more. Okay, what about this one? What do we think is wrong with this one? Any thoughts? I would probably have switched these intervention methods or their measures to the rows and had before and after across the top. It would have looked a little cleaner. They do note what is significant with this little asterisk. Everything except social functioning was different from before to after the intervention. So that's basically all this is telling you. They don't tell you the t-score, the t-value in this table, so that's kind of interesting. But they do tell you that these two are different from one another. What test is this, an independent or paired t-test? Paired. So before to after means it's paired. So this is about quality of life between two different types of headache groups. So what type of test was this? Independent or paired? Independent, yep. So they had 46 people in this transformed migraine group and 44 in this other migraine group. So this is just telling you some of the demographic information that we did in SPSS back before fall break. And then these last three, I think, are where they actually did the independent t-tests. But none of them were, oh, they are significant. So they have little asterisks next to the name of the value instead of in the actual value itself, which is kind of confusing. So I don't really like this one because that's confusing to me. And there's a lot of things down here. Okay, one more, I think, yeah. So this talks about coping strategies for distressed respondents compared to non-distressed respondents. So these are high school students. This gives you a ton of information. So the coping strategies are on the left, and then you have the two conditions, or your independent variable, which is non-distress and distress. The number in each group, that's kind of weird because they keep repeating it down the whole thing. I don't like that. The p-value, so they indicated really, really low p-values, which means they're really certain that this is actually different. They have the mean values, they have the standard deviation, and then they also included the confidence interval. So it looks like, was anything significant? No, nothing was significant. So they indicated that this asterisk would mean it's significantly different. And they found that there was no significant differences between people who were distressed and not distressed. Interesting. Any questions about this? So one of the homework questions is an example of a table, and you have to give a couple answers on it. That's why I talked about it a little bit. Okay, let's see. Any questions about using SPSS for this homework? Do you want to walk through the tests again? Were they easy enough that you're fine? Easy enough? Okay. Then I will show you the homework. So homework due tomorrow is homework 5 and 6 by 11:59 p.m. tomorrow. So if you didn't do it already, you should do it really soon. Discussion board 3 is due next Monday. That is creating your own health-related example of an independent t-test and your own example of a paired t-test. So using some of those examples I had in the PowerPoint or an example from the homework or the book, come up with your own example. Don't copy and paste those. I wrote them, I know what they are. If you copy and paste them, I won't give you credit. But you can base your wording off of that. So pick something else instead of cholesterol and gender. This Module 7 overview has links to the homework, the PowerPoint, that statistical matrix. It'll be more important in like 2 weeks than it is right now. The SPSS output and that SPSS data file. This website is really, really great. If you are having problems or struggling with SPSS, I recommend you go and look through this. It gives you step-by-step introductions to the environment, how to use different things. It has sample files, all sorts of stuff. And if you go to analyze data, it has the paired samples t-test, and it shows you how to do it step by step. And it has the independent samples t-test as well. So this is a great resource just in general to have in your back pocket for the future, because it lists a lot of stuff about SPSS. And then these are those decision-making things I was talking about that are similar to this statistical matrix but may make more sense to your brain. So there's tables on these two websites. So this one's similar to what I have, and this one is kind of similar, but it also has links to how to do them in SPSS. So if you want to get fancy, you can use this one. And then these other two are actually interactive ones. So you answer some, I guess that one doesn't work anymore. So the second one, oh no. So you answer some questions. So how many variables are there? Is there one variable, 2, 3? I don't know, let's say 2. And then what's the scale of measurement? So you pick which one it is. 1, and then in this case it breaks it into interval instead of continuous, but continuous and interval are the same. So maybe one's interval and one's nominal. Is the interval variable dependent? Well, if you're doing an independent samples t-test or a paired samples t-test, it will be, so yes. Do you want to measure the strength of a relationship or test the difference? So we're doing significant differences, so that would be significance. Are you willing to assume that the internally scaled variable is normally distributed? Yes. We're assuming, based on what we learned last week, that everything from now on is normally distributed. It might not be in real life, but we're going to assume it is. And homoscedasticity, we're going to assume that that's true too. So, this is an analysis of variance, what we're going to talk about later, based on what I picked. So it tells you which test you should use based on your information of what variables you have available to you. So if that makes more sense to you, feel free to use that moving forward. Okay. So that's in that first thing. And then in the second one, it has a summary, some more examples, and the recordings from last year, as well as I'll post today's class at the bottom here. So you'll be able to look at that, because I'm super exciting and you just want to listen to me talk so frequently. Then the PowerPoint, and so everything's also on here. And then homework 7 is due in 2 weeks. So you have 2 weeks to work on this, but don't wait for 2 weeks because you'll probably forget stuff by then. And we're learning new stuff next week. So I recommend you do this sooner, but you do have 2 weeks to work on it. So the homework, there's a bunch of questions. The first one is just looking at these scenarios and identifying the dependent variable, the independent variable, which tests you're going to use, an independent or paired t-test, and why you chose that. So if you're just randomly guessing, you won't know why, but make sure you put why. And then same thing for the second part. Then number 2, you have to enter this data into SPSS. So let's practice so that you all are ready. Because I talked how to do it, but I didn't actually show you. So we're going to open a new data file, and we're going to enter this data. So let's just walk through this example. Higher concentrations of cholesterol indicate higher level of risk, blah, blah, blah. There's a lot of words here because I want you to have to pick out what the dependent and independent variables are.